Welcome back to a new video. In this video, we are going to create a data science project using Python. We are going to do data cleaning, data analysis, data visualization, feature engineering. We are going to train machine learning models, and we are going to create a web app using Streamlit. I will be sharing the dataset link in the description of this video. If you want to do the project with me on the video, you can download the dataset from description. Let's start coding. So this is the dataset that we are going to be using through this video, and we are going to build our project on this dataset. So it says company employees and dataset for practice for analysis and visualization. I'm going to leave this dataset's link. You can just visit that link and hit this download button for downloading the dataset. So I'm going to be reading about the dataset from this data card a little bit, but we are going to explore more in the code editor. So it says employee data analysis. This dataset contains detailed information on employees across various departments and countries, capturing key aspects of their employment and performance metrics. Okay, so we have the features in here, and we are going to look for them in the code editor. This one is important: job rate, a performance rating. So the bigger number, the better performance, in my opinion. So let's take a look at the dataset. We have a Excel file in here, and we have 15 columns. We have an ID column in here: first name, last name, gender, start date, years, department, country, center, monthly salary. And let's look at the others: annual salary, job rate, sick leaves, unpaid leaves, and overtime hours. So great. Okay, I think we are ready to go. You can find this link in the description and hit this download button for downloading the dataset. Okay, see you in the code editor in a second. So I'm in Visual Studio Code, VS Code right now. You can use any code editor that you want: PyCharm, Spider, Google Colab, it doesn't matter. And I love VS Code, so I'm going to be using that in this video. And I'm going to close this welcome page, and I'm going to open this file section. As you can see, I have the employees file in here. We are going to work on that. And I saved the Kaggle link in here for sharing it with you in the description of this video. You can find this link in the description of this video. And I'm going to close that, and I'm going to start by, for the analysis and modeling side, I will create a Jupyter notebook like analysis and modeling.ipmb. So here it is, and I'm going to say select kernel. I'm going to select 3.11 for Python, and I'm going to start by importing pandas. And now what I'm going to do is I'm going to copy this employees.xlsx, and I will say pandas with Excel, and I'm going to paste this in here for seeing if it's loading successfully. Yes, it is. So I'm going to save this to something like data, and from now on, if I call the data, I'm going to get that data frame. Great, so we successfully loaded our data set. And now I'm going to say .head. Defaultly, it returns the first 5 rows of the dataset. You can specify the default number by writing a number in here. Like if you say 3, you are going to see the first 3 rows. And if you say tail, you are going to see the last 3. And defaultly, tail returns 5, but I will go with head. And let's talk about the columns we have. So we have index column, first name, last name, gender, start date, years, department, country, center, monthly salary, annual salary, job rate, sick leaves, unpaid leaves, and overtime hours. So we have both numeric and categorical columns, and we are going to do our analysis on this dataset. So for the starting, I will say data.info, and here's the general information about the dataset. So at the data types side, we have 1 date time, 1 float, 7 integer, and 6 objects. And our range index is 689, and we can see the memory usage along with the non-null count. And now what we can do is we can say data.shape. For seeing the column and row count, we have 689 rows with 15 columns. Okay, so let's start by cleaning our data. Let's check if we have any NA valid rows. So I will say data is NA, and it's going to return me cell-wise booleans like true or false for every cell. And when I say sum to it, we are going to get the general count. So it's 0. Great, we don't need to do anything. But what happens if we have any values in our data set? Then we can clean them using data drop NA, and we need to specify in place equals to true, because otherwise it's going to not modify the original data frame. So let's write like for cleaning NA values in the data set. Great. Also we can say like dropping. Okay, let's check for the duplicates. Data duplicated. So it's going to return booleans again row wise, and if you say sum, we are going to get the total of the duplicates. So duplicate means exact same. If two rows are full same, then we can identify them as duplicates. So after calling that, we don't have any, but we can drop it by data drop duplicates in place true if we have any duplicates in our data set, and we can call it like for dropping duplicates. Okay, so I will call the data again like this, had 3, and actually it's going to be 3. Let's check. Okay, what we can do now is we can analyze this data set. So I'm curious about the gender counts. So we can do data that value counts, and actually this is a mistake. I need to specify the column that I'm going to look like this, and we have 449 male with 250 female. So I'm going to import matplotlib.pyplot as plt in here. I'm going to use a pandas plotting technique, but I'm going to give like x label, y label. That's why I need matplotlib in here. And in here, by the way, it's a pandas series. Like you can say sort values, and let's say ascending true. You can change the order like this, ascending true or false, doesn't matter. It's defaultly false like this in this example. And now I'm going to create a pie chart from this. Let's say dot plot, and let's specify the kind as pie, and I'm going to make it run, and we have this right now. Great. So I'm going to make this look a little bit better. So I will say plt.title pie chart of gender column, and since I have this count text in here, I want to make it disappear. So plt y label empty, and I will say plt.show for making this disappear, and I'm going to make it run, and it seems better right now. Great. So next I'm going to call data again, data frame head 2. Actually it's data head 2, and I want to create a histogram of job rate. I'm curious about that. So for that I will say plt.histogram, and I'm going to give data job rate like this, and here it is. Let's make it look a little bit better. So for that I will say plt.title and histogram of job rates, and then I will say plt x label rate, plt y label count, and at the end I will say plt.show like this. So here is our histogram, and we can see that the most is on the bigger side of the average. Like we have 4.5 and 5s heavily, and 3 to 3.5 heavily, and the most of the employees in the better side of the average. Okay, so by the way, we can get the summary statistics for that column too, like data frame, and my average saying was just an estimation. Like our estimated average is going to be around the 3.5, but let's check it out. I will call data in here job rate, and I will say that describe. So it's going to return me the summary statistics, and mean is as I expected 3.58, and also we have standard deviation of 135. Okay, great. So now what I'm going to do is I'm going to call the data, and let's do some group bys. Like let's group our data by department and see the salaries. So I will say data group by, and I'm going to group it by the department, and then I'm going to check the salaries like annual salary that let's see by averages. So actually department, there was a typo. I'm going to write it like that, and it's going to work smoothly. Okay, so here is our result, and As I said, it returns a panda series. I'm going to manipulate it like sort values. I will say ascending false like this, and now we are going to get this. So surprisingly, human resources at the top. So I'm going to create a bar plot from this, but one problem, we have a lot of features. Like I will show you that plot and kind is going to be bar, and when I set this, you are going to see we have a complex plot in here. How we can fix that is we can easily do like, I can take this, cut this out, and I can make it run. Then I can say that head and 7 for only plotting the top 7, and then I can say that plot kind bar, and now I can create my plot like plt.title, and I'm going to give the title like average salary graph by department, and I will give it the X label like department and Y label like average salary, and then I will say plt.show at the end of this, and we are going to get this. Okay, nice looking plot. So HR is the first, and IT is the 6th, and research and development is the 7th. Okay, let's do more. I will say data, and in here what I'm going to do is let's group our data by, let's say center, and let's check the monthly salary. Okay, so we are going to group by center, and we are going to check the monthly salary. That means like this, and as we can see we have a result. Let's sort it out and set ascending as false, and okay, no quotes, I mistype it, and we can see that east is the leading one. Okay, let's continue data, and now I will check. Let's check how many unique values we have at the countryside. So I will say data country dot unique like this, and we have Egypt, Saudi Arabia, United Arab Emirates, Syria, and Lebanon. So let's check the job rates by country. So I will say data group by, and I'm going to group it by country, and then I will say, let me check the column name, job rate dot mean like this, and I'm going to sort it out, sort values, and I will say ascending false like this, and here is our result. So again, let's create a good looking plot from this. Plot kind bar title job rates by countries plt.x label country plt.y label job rate average, and at the end I will use plt.show like this, and here is our bar plot. So we can see that Saudi Arabia is the leading one, and the one which is at the lowest side is Lebanon. Okay, great, but there is no much difference, by the way, so there is no big differences. Okay, so I will call the data again, and let's see what else we can look at. Okay, let's create a histogram plot of this overtime hours. So I will say plt.histogram, and I will give data overtime hours, and I'm going to say make it run, and we can like, let's say title histogram of overtime hours, and we can do X label like overtime hours, Y label like frequency, and we can use plt.show at the end of this. So here it is. So also let's get the summary statistics for that. I will say data overtime hours dot describe, and we will get mean is 13, and we can see that there is no out of overtime hours in our data set. Okay, I will call data again, and now what we can do is I will say like, I'm going to check the annual salary distribution. I will say data annual salary dot describe, and let's see how it looks. So the mean is 24,000 and we can see that standard deviation is 9,000. Okay, now we can go to the modeling side. So for predicting the salaries, I'm not going to do something like too complex. I'm only going to include two columns such as years and the job rate in here. I'm not going to take anything else. So it's going to be a basic regression problem since our target value is going to be this annual salary and it's continuous. So we are going to be checking that if we can predict the salaries good with years and job rates, and it's not a problem if we can't, because we are going to create a user interface for the model, and improving the modeling side is up to you. We are just doing the project in the way that analyzing, cleaning, visualizing, modeling, and creating a user interface side. I'm not going to be too much focusing on the modeling side, and we can directly go. So at the data.column side, let's go like for the X, I'm going to do data and I'm going to filter the years with job rate in here, and at the Y side I'm going to filter the annual salary. So here it is, and then we are going to apply train test split. So what is it? Imagine like we have 5 data points like this. Let's do it like A, B, C, D, E. They are all our data points, and when we set our train test split like 0.2 for the test size, it means that the 20% of the data, in this case one part of it, is going to be in the testing set and the others are going to be in the training set. And with the training set, we are going to be training our machine learning model, and with the test set, we are going to be evaluating its performance on the test data. So for that, we will say from scikit-learn.model selection, import train test split, and then we will say xtrain, xtest, ytrain, and ytest, then train test split, x, y, and test size of 0.2, and then we are going to have our x and y training and testing sets ready. Like x train length is going to be 551 and length of the y train is going to be actually 551. I'm sorry, I was going to write like test, that's why I shocked. In the test size we need to see something smaller, 138. For the X test we are going to see 138, and for the Y train we are going to see 5512. Okay, so since our X values are in a similar range, I'm not going to use any sort of scaling in here, and now I'm going to train a linear regression model. So I will say from scikit-learn linear model, I'm going to import linear regression, and then I'm going to initialize it like this, linear regression, and I'm going to train my model on the training data I have, Y train. Then I'm going to make predictions with X test, and here they are, and I'm going to save it to something like predictions linear regression. I'm going to store it in that, and then I'm going to import mean absolute error from here, and then now I will call mean absolute error with X test and Y test we have, and there is an error. So Y2 and Y prediction have different number of outputs. Let me quickly check. Linear regression. Oh, okay, my bad. I will say predictions linear regression like this. And now here is our mean absolute error. This depends on your use case, if this number is good or bad. Like you can just, like, what was our column name? It's annual salary, data annual salary that describe. You can compare the value. It's up to your case and success level. I'm going to call the X. So the X order is years and job rate. I'm going to keep this in mind because in the Streamlit user interface, the development side, we are going to need this information. And now what I'm going to do is I will say import joblib. Then I'm going to use joblib.dump method for setting the linear regression, like linear model.pickle, and I will give linear regression like this. Actually, the order is wrong in my opinion, so we can change it like this. And now we are going to have linear regression model.pickle in here. So our model is stored in here with its all methods and features. So we are done with the analysis and modeling side. Let's summarize what we did from start, and then we can start to creating our user interface web app, machine learning web app on Streamlit. So we imported pandas, we saved our data, then we checked, analyzed it, we did some data cleaning, we looked at what we can do, and we created plots, visualizations, we made group bys, we checked our data's features, we get the summary statistics, we created histograms, then we separated our X and Y, and then we split our data into training and testing sets. Then we trained a linear regression model, and then we made predictions, get our mean absolute error. Now we dumped it and we are ready to create our Streamlit machine learning web app. So for that I will say app.py, and then I'm going to save this notebook, doesn't really matter. I'm going to close other stuff, and now what I'm going to do is I will import Streamlit, and then I'm going to import joblib, and I will import numpy, and then I'm going to give it a title like salary prediction app, and then I'm going to add a divider. I use them a lot for making the user interface look better, and then I will say streamlit.write with this app you can get estimations for the salaries of the company workers, employees, let's say it like that. And then what I'm going to do is I'm going to take the inputs. So let's say, like, let me check the order again, and let me find an X in here. It's years and job rate. Okay, so for the years side, I will say years is going to be Streamlit number input, and I will say value, let's start to it with 1, and step is going to be 1. It's defaultly 1, but I want to mention that like this, and minimum value is going to be 0. So we don't want it to be less than 0. And at the job rate side, we will say Streamlit number input, and value is going to be, let's say 3.5, the average, and step is going to be 0.5. Remember that you need to all give floats in here, like you need to use floats, and minimum value is going to be 0 like this. And these are going to be our inputs. Then let's add them in something like X, and it's going to be like years and job rate. Then we are going to add a button like predict, and it's going to be streamlit.button. Press the button for salary prediction, and let's add a divider before that, and after that like this, and we will say if predict, and at the end we will say else. Let's write it first. Please press the button for app to make the prediction, and then we will say if predict, it's going to be, let's display balloons when it's clicked. Then what we are going to do is we are going to say like X is going to be, let's say x1 is going to be numpy.array, and we will give the x like this, but we can give it with brackets since we need to pass two-dimensional array inside the predict function, and we are going to get the prediction from, I forgot to load the model, so let's load the model firstly in somewhere, it doesn't matter. Let's do it in here. So model is going to be joblib.load, and we are going to copy this pickle file in here like this, and then we will say model.predict, and we will give x1 like this. Also, what I'm going to do is I will say as mp in here in the importing of the numpy, and then I'm going to write the prediction like Streamlit write prediction, and we can give it to something like salary prediction is, and we can say this like this, and our app is ready to go. So I'm going to save my file, then I will say Streamlit run app.py, the file name I mentioned in here. So I'm going to make it run, and this is going to open a new page in my browser. Actually, it throws an error. Let me quickly check. Oh, we didn't give the labels in here. Okay, let's give them. So years, enter the years at company, and for the job rate side, I'm going to say enter the job rate, and now it's going to work out smoothly. I'm going to save the file again, then I will say Streamlit run app.py like this, and now as you can see we have this local URL in here. Normally it automatically opens your browser and this page, and if it is not opening this one, you can go to this website on your browser, and I'm going to be re-recording in a second in my browser. So here I am at that website, localhost website. By the way, we can close our data and we can change this interface to, let's say, light like this, and let's take a look at our app. Okay, I'm going to make it dark, it's too light for me. And salary prediction app. With this app you can get estimations for the salaries of the company employees. Years at company, let's say 3, and enter the job rate, let's say 4, and I press the button for getting the salary prediction, and I get this. But let's format it better, so I'm going to re-record in code editor. It's working smoothly, app is looking nice, but what I'm going to do is I'm going to just change how this number displays in here. So in here what I'm going to do is I'm not going to kill the terminal, I will come to here, then I'm going to take 0 in here, and also I will say to floating like this, and I will save it. Then in here I'm just going to press this button again, and this time number displays really good. Great. So we have this prediction app, like we can make different predictions in here with our app, and our machine learning web app is ready. So it's great. Let's summarize the code and then we can finish the video. So in here we import Streamlit joblib numpy, and then we give it a title like salary prediction app. We use dividers a lot, and I write, with this app you can get estimations for the salaries of the company employees. Then we take number inputs for the years and job rate, then we load our model and we add a button to our web app, and if that button doesn't click, we print please press the button for app to make prediction, and if it's clicked we display balloons. Then we set our x1 as numpy, and we get our prediction from the model, and we write salary prediction is prediction. And also we do these two operations, like selecting the first index and this floating operation for making it look better. So that was all for the project. I have like more than 30 or 40 projects on the channel. You can just check the data science projects playlist for more videos like this. Also I share the data science bootcamp, which is completely free and it's about 7.5 hours. You can check that out too. Thanks for watching.
I will be really happy if you can like and subscribe. Let's get to the outro.
Thanks for watching the video. I'm sharing new data science videos every week. You can subscribe for more videos like this. I have a playlist of data science projects which has more than 30 data science projects. You can check that playlist from the cards of this video. Have a great day.